Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 11.1, Problem 3. This is Section 11.1, Problem 3. It says, consider the function f of x equals x minus 1 times x minus 2 over x minus 2, and find the limit as your input or x value approaches three different numbers. So the first one says, find the limit of x minus 1 times x minus 2 over x minus 2 as your input value approaches 0. So there's no reason why we can't just put in a 0 wherever we see an x. Nothing bad will happen. So on the top of the function, the left parentheses x minus 1 will become 0 minus 1. The right parentheses x minus 2 will become 0 minus 2. And in the denominator, x minus 2 will also be 0 minus 2. And now the left parenthesis on top, 0 minus 1, becomes negative 1. The right parenthesis in the numerator, 0 minus 2, becomes negative 2. And in the denominator, 0 minus 2 is another negative 2. And now in the numerator, negative 1 times negative 2 is positive 2. You have a negative 2 below that. And positive 2 over negative 2 will reduce to negative 1. So that's the value of the limit. As your input gets very close to 0, the output will get very close to minus 1. In other words, the input is how far on the x-axis from side to side you've gone. The output is how far up or down on the y-axis you go to get to the graph. Now, part B, we want to take the limit of the same function, x minus 1 times x minus 2 over x minus 2, as the input value approaches 2. Now, the problem with this is that the denominator will go to 0. We cannot actually just put in a 2 for an input the way we did in part A. We have to cancel the x minus 2 in the numerator with the x minus 2 in the denominator. Now in part A, we could have actually done that and gotten the same answer of minus 1. It would have worked. But we could do it either way and would get that minus 1. In part B, we have to cancel the x minus 2 in the numerator with the x minus 2 in the denominator, because I cannot allow any denominator to be 0. So really, I'm taking the limit as the input approaches 2 of x minus 1. So that x minus 1 will go very close to 2 minus 1. Which is really positive 1. So even though I cannot put in a 2, because what happens to the denominator is I put in values really, really close to 2, the output or height gets really, really close to 1. So as I put in input values, or values along the x-axis from side to side of things like 1.999, I can put that in. The output or height on the y-axis gets very close to 1. And then finally, part C, find the limit of the function x minus 1 times x minus 2 over x minus 2 as the input approaches negative 2. So with this one, negative 2 is fine in the denominator. The answer you're going to get is negative 4 in the denominator. So I can just put in that negative 2 wherever I have an x. So the upper left of the function, x minus 1, becomes negative 2 minus 1. The upper right in the numerator, x minus 2, becomes negative 2 minus 2. And in the denominator, the x minus 2 becomes negative 2 minus 2. Now, like in part B, I could cancel the x minus 2 in the numerator and then the denominator. And that would take me right to the answer of minus 2 minus 1 should be minus 3. But it should work either way in this case. For part C, because the denominator is not going to 0, I have the option of doing it either way. So this upper left parenthesis becomes negative 2 minus 1 is negative 3. The parenthesis in the upper right of the numerator, negative 2 minus 2, becomes negative 4. In the denominator, negative 2 minus 2 is another negative 4. So on top, negative 3 times negative 4 is positive 12. But it's divided by a negative 4. Positive 12 divided by negative 4 is negative 3. So that's the answer. As your input value, or value on the x-axis, gets really close to negative 2, the output, or height that you get really close to, is negative 3.